Top. Welcome back, welcome back, welcome back. I'm Lisa Blackburn. This is my video channel, my YouTube channel, for everything I want to talk about science and math. And today we are in part 4 of AP Chemistry Unit 1, covering chapters 1 through 3 in our AP Chemistry book. And we've been talking about stoichiometry. And we went through yesterday the one where it was gram to gram banana flavoring. Okay, so everybody said they understood it, so they're ready to go on. Okay, so this time, how many moles? So if I was doing this problem, I would annotate it, and I'd put a little question mark over moles. The reason why is I'm a little bit spacey, and I'll get so happy and excited to be doing a problem that I'll run off and solve the wrong problem. Because I didn't pay close enough attention to what they were asking, I'll get something else they didn't ask for. So it helps me to focus if I annotate it. So I would put a question mark. Are produced by 14,000 moles of hydrazine rocket fuel, N2H4. So I find N2H4, I put under it how many moles I have, and what I'm asking for is how many moles. So there's my question right there. So I was going from moles to moles. So do we look at the molar mass when it's mole to mole? Yes. No. You only do molar mass if it's grams. That's why we all have to imagine our delicious graham cracker and put peanut butter on it in your mind. Now my peanut butter is Smucker's All Natural. I don't like Jif, I don't like Peter Pan. Those are all Crisco with peanut flavoring. It's got to be the all natural. But you can leave the peanut butter off if you want. But then you got to mentally put M&Ms on it. And imagine yourself eating this delicious snack of graham cracker and M&Ms. Because the only time you do molar mass, and that's why I have M&Ms on my periodic table, is if you only do it if it asks for molar, if it's grams. Grams, molar mass goes with grams. Hello.
It's me. Hey.
Yes, what's the worry on?
Zach. I'm getting something from Zach. All from Deco.
You're all from Deco. Well, yes, I need like a treat.
A treat?
A treat. Deco people bring me treats.
We'll see what I can do.
Okay, see what you can do. All right. So no grams, no molar mass. So instead we just go straight to the mole ratio here. And you always have to balance the equation. It's 2 to 4. We'll review that. There's 2 nitrogens, 2 nitrogens, 4 hydrogens, 2 nitrogens. So that one needs a 4. 4, you would, I said it wrong. That looks like it needs a 2. But then I notice these oxygens. I have 4 here and 1 there. So it's always good to take a look at those oxygens. So have to erase everything, go back. Now I'm going to put my 4 here. 4 times 2 is 8 hydrogens. I go back over here and put a 2. That's got 8. 2 times 2 is 4. And then plus 2 is 6. 2 times 3 is 6. Watch out when you're balancing for something that is in 2 different chemicals. Did everybody get with that balancing? Okay. So now we just draw our U. We start with what we know. 14,000 moles. We push moles to the denominator. We go around the circle to see what number goes with it. 2 does. What goes on the other side of the fraction bar? 2 dots is a fraction in math. You learned that in ratios. And so on the other side is 4 moles. And then, so it's just 14,000 times 4 divided by 2. 14 times 2 is 28. You could have done that one in your head almost. We good with that? That is the easy one that trips people up. Because they get into such a rote of doing it by memory, how to do grams, that when they're throwing something different, then it's like, oh, easy, and they get tripped up. They want to put grams in it when they don't go. Okay, next one. Find the mass of sugar, C6H12O6, required to produce 3 liters of carbon dioxide gas at STP. The STP just means you don't have to worry about anything. You can just do the problem. So we're going liters to grams. So first of all, what number do you use instead of molar mass if it's liters? And it's over here on our box. If those of y'all who had me before, you'll remember your box. 22.4 liters. And then if it's atoms, it's 6.02 times 10 to the 23rd. Atoms, particles, anything like that. Okay, do y'all remember that a little bit? So you have to memorize that, 22.4 liters per mole. So what I'm looking for is a mass, so that's grams of sugar, so I put question mark grams of sugar. What I'm given is 3 liters of carbon dioxide. This is delicious graham crackers, so what do I need?
Moles.
Molar mass. So I look it up. 6 times 12 plus 12 times 1 plus 6 times 16 is 180. I don't need molar mass here because I have liters. It's 22.4. I make sure my equation's balanced and I draw my circle. Hello. Good, how are you? I'm teaching right now, but what do you need? Uh-huh. I can. I'll call you just as soon as they all start working on their math. Okay, thanks. I gotta call Miss Hayes. Y'all remember that. Y'all remind me when I'm done. Okay. Anyway. Okay, so our ratio is 1 to 2, and I had already balanced it for you. So now notice if we go the other way. So we start, what we know is 3 liters. We push liters to the denominator. The number that goes with liters is 22.4. What's on the other side of the fraction bar? 1 mole. Go around the circle, moles come down here. What moles are they? They're 2 moles. What's on the other side of the fraction bar? 1. 1 moles go down here, they get pushed down here. It's that mole right there, has an understood 1. What's on the other side of the fraction bar? 180. So it's 3 times 180, enter, divided by 22.4, enter, divided by 2, enter. Do it like that or else it'll mess up, or else you gotta use parentheses. And you should get 12 grams. So everybody who's got their calculator out should try it and make sure you can get 12 grams. Make sure you remember how to get this to your calculator. So you feeling pretty good now? We know what to do if it's grams. We know what to do if it's moles. We know what to do if it's liters. And next we just have to know what to do if it's particles, things like that. Give y'all a second to do that. Y'all ready to talk about the next one? Okay, our next one says, how many molecules of hydrogen are produced? So that's my question. By 6 grams of water, that's a mass. So if it has molecules, particles, atoms, anything like that, the number that goes in that line is Avogadro's number. 6.022 is what I'm seeing you being used on AP problems that I'm looking at online. Times 10 to the 23rd, things per mole, whatever thing it is. So first you have to balance it. 2 hydrogens, 2 hydrogen, 1 oxygen, 2 oxygens, got to put a 2 here and a 2 there. We're given 6 grams of water. We want to know how many molecules of hydrogen gas. So because we have delicious graham crackers, we need M&Ms, we need the molar mass. Molar mass of water is 18. You'll probably end up memorizing that. 16 plus 1 is 18 grams per mole. The ratio is 2 to 2. And if it has molecules, atoms, particles, anything like that, formula units is what I saw today. 6.022 times 10 to the 23rd molecules per mole. So you start with what you know. I didn't draw my circle here. I should have drawn it that way. Grams go to the denominator. You go around the circle. 18 goes with grams. 1 goes with moles. It's that mole right here. Push it to the denominator. 2 goes with that mole. On the other side of the fraction bar is that 2. Push it to the denominator. It's that mole right here. What's on the other side of the fraction bar? 6.022 times 10 to the 23rd. Multiply 6 times 2 times 6.02 times 10 to the 23rd. Enter. Divide by 18. Enter. Divide by 2. Enter. Now, isn't 2 over 2 the same thing as 1 over 1? And can't you just leave that out? Yeah. Mathematically, yes. But no. On the AP test, anything like this, you're going to be showing your work, and they will count it wrong because you've got the wrong work. You didn't, even if you get the right answer, you didn't show the right work. You didn't show that you knew to multiply by the mole ratio. So your work is a conversation, between you and the grader, showing the grader what you know. So you have to write neat and be clear and show your work. Okay? Now on the multiple choice part, they won't look at any work. Do whatever you want if it's multiple choice. But for the multiple choice part, you don't use a calculator. It's all going to be more conceptual, so you wouldn't be doing this anyway. So everybody understand that? Okay, last page here. Woohoo! Okay, so limiting reactant is our last little thing on this test. And so if you had 152.5 grams of carbon monoxide and 24.5 grams of hydrogen gas, making methanol, CH4O, sometimes you see it CH3OH, what is your limiting reactant? What is the thing? So what it is my example I always use is brownies. If I am going to be taking brownies to a party, and I signed up that I was bringing 4 batches of brownies, and I go to Food Depot, my favorite grocery store, because they're cheaper than Kroger and Publix, and they've got Ghirardelli brownies, my favorite brand, and I get 4 boxes, and I go home, and I'm ready to make the brownies, and I've paid my water bill, so I've got plenty of water in the sink that I can use. I have plenty of oil that I have a big thing of, but I only have 1 egg. Can I make 4 boxes of brownies without substituting applesauce or something like that? No, I cannot. So my limiting reactant is eggs. Does that make sense to you? So this is the same thing with this chemical. One of these is gonna be used up first. And we can't tell by just looking at it which one it is. So what you do is you do the problem twice. One time with this as your given, and one time is with that as your given, what you know. Whichever is less is what really happens. Do y'all remember that from honors? Okay, so here, first of all, you balance your equation, it's balanced. So for what I like to do is use 2 different colors and put it in one chart. You can also rewrite the equation and make another chart. So I put for carbon monoxide, that is what I was given. For the hydrogen, that's what I'm given. And for both, this is what I don't know. These are grams. I have delicious graham crackers. I need M&Ms. So I look up the molar mass on the periodic table for all 3 of them. I look at the ratio. This is 1 to 1, and that one is 2 to 1. Does everybody understand where I got those? Okay, and so I do it the first time with carbon monoxide. I put what I know. I push grams to the denominator. The number that goes with grams is 28. What's on the other side of the fraction bar? 1 mole, that mole right there. I push it to the denominator. This 1 mole goes right here. That 1 mole goes here. I keep going around. I push it to the denominator. It's that mole. It's an understood 1. On the other side of 32, I multiply 152 times 32, enter. Divide by 28, enter, and I get 174 grams. Now I do it again. Same thing, one more time. This time I've got 24.5 grams. I push it to the denominator, and I put 2 grams on the bottom and 1 mole on top. I push it to the denominator. I put 2 moles on bottom and 1 mole on top, because these are moles of hydrogen. That's mole of methanol. Now I go around the circle. I put moles on the denominator. It's that mole right there. I put grams in the numerator. It's that right there. Grams cancel out, moles cancel out, moles cancel out. I'm left with grams. 24.5 times 32, divide by 2, enter, divide by 2, enter is 196. Now I ask myself, which is less, 174 or 196? 174. Would you rather have $174 or $196? 196. So that means 174 is less. So that's what really happens. So carbon monoxide limits the reaction, and hydrogen gas is in excess. That's the words that go with those ideas. Do you feel everybody remembers that? Okay. So then this always leads into the next problem, which is, well, what if you do it in lab and you only got 150 grams when you were supposed to get 174? what was your percent yield? So a lot of times in lab, you don't really get as much as you're supposed to get. Maybe you spill a little. Maybe you don't get it all out of the beaker. Maybe it shows that you have too much because you didn't dry it. That happens a lot. So the formula is the actual divided by the theoretical times 100, or what you really got over what you were supposed to get times 100. 150 divided by 174 times 100 is 86.2%. And that is everything you need to know for Unit 3. Now, you need to read your chapter and make sure you understand all of that too, because I was looking at the test I'm going to give you, and it's a little bit picky. But we have all the way until next Thursday to learn it. So we have a whole week. We'll do a lab for part of it. We'll do lots of worksheets. So I'm going to stop the video, and I'll tell you what we're doing next. All right. Like, share, subscribe. Science is great.